11 on that. So Mark Vogan, the weather guy here, he's like our local weather guy,
Hmm.
but he does a lot of world and global and speculation on weather. He was interested in because I admin for his Sunday YouTube live thing. And he's like, "Oh, I need to know
Okay.
more about solar maximum and what does that mean for weather?" And I was like, "Well, I could try to have an interview with Scott if you wanted." And he's like, "Oh yeah, yeah, ask him." And some of the questions I was like, "That's probably not gonna be much of what Scott
S-
does," but
Space aliens. I'm not saying it's aliens, but it could be aliens.
it could be. You have the Terminator, you have this, you have all kinds of scandalous things going. So the first thing I guess we should spell out is your current role, your history. So what got you into studying the sun? I mean, obviously you had a lot of stuff in you went to University of Glasgow. So Mark's from Glasgow as well, so that's a nice
Oh,
tie-in.
okay. Okay.
So I mean, and you were a director at the High Altitude Observatory, so that's something interesting to me. So I'll probably ask you about that because I'd like to know
Okay.
where they're at with bringing it back online and that kind of stuff. But he really
Yep.
wanted to know more about what your background is and what possible implications the sun's cycles has on terrestrial weather, if that's something that you
Oh.
dabble into. And
Ooh.
I was saying to him, you
Ooh.
probably don't. There's probably a lot of
Right.
speculative science. But
Well,
yeah.
we have noticed some patterns. So let's put it that way.
Okay. So firstly,
So
talk
so
about
there's some
what
stuff
got you
there, but it's
started in all of this so that we don't go down the rabbit hole.
um I mean that itself is a huge rabbit hole, complete accident. So I was really interested in medical physics.
Right.
So physics and math graduate at Glasgow. I was really interested in medical physics at the time. My nephew was really sick with cancer,
Wow.
and so I was struggling with things to, how could I use what I was learning to help, right? Not maybe not even help him, but help
Help
kids
someone.
later,
Yeah.
right? So I thought radiation oncology, you know, and medical physics. As a physicist, getting into medical physics and medical imaging and things like that. So I tried to go down that path, and I get offered what? I get offered an internship, not like a studentship, to do the master's program. So there's a big master's program in medical physics run out of Geordieland.
Mhm.
Um, and so I wanted to go do that. And I can't exactly remember why it fell through or I fell through. And then one day I got a phone call from who ended up being a guy called John Brown, Professor John Brown, who's the astronomer royal for Scotland.
Yeah.
And he was casting looking around the department looking for students to do a PhD project in a particular area. And I was hungover one morning. I got this phone call. "Ah, this is Professor John Brown. Is this Scott Baxter?" Yes. I spoke to John Chapman. So John Chapman um, ran the solid state physics group in Glasgow. And so they do all the, medical imaging, all of that stuff was through them.
Yeah.
And he said, "Will you come in and talk to me? Because I've got an interest in you do tomography and medical imaging. So I've got a interesting project like to run past you." I said, "I've never done an astronomy class in my life." Right. Because I was a dual major, all of our time was spent on math,
Right.
basically.
Yeah.
Right. So applied math, all kinds of math classes, and our physics classes were the core classes. So, but I'd done all the quantum mechanics and all that stuff, but I'd never had the time to do elective classes. So I went in, interviewed with John, and he offered me a PhD spot to do a problem with the sun, and it basically kind of like an MRI,
Ah.
but so you measure the light and then you try to break down, given its wavelength, try and establish what ions, what what are the constituents of the plasma that give rise to that light,
Uh-huh.
right? So is it, if it's in the corona, can you tell, the balance of nitrogen versus iron versus blah 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 blah,
Right.
right?
So all the
Versus
constituents
carbon,
and classing the
right?
stuff.
So it's like doing a DNA thing, right?
Ah, yeah,
Right,
yeah.
but from spots of light, right? So it's an inverse problem. So you take all these measurements. So I built, back in the day, it wasn't called AI, but I wrote my PhD thesis on genetic algorithms.
Oh, wow.
So we're using basically AI to try and invert these solar spectra to extract information about the source region, right?
Right, right,
So yeah, so I did that, completely came at it from I've never done this shit before
right.
approach. And then I got into, John was good friends with the guy that worked here. They invited me over for the summer, and I worked through the summer, and then they invited me back the next summer, and loved it. Absolutely loved it here.
Yeah.
But the weather was quite different from Glasgow,
Yeah, just a bit.
and I did my PhD in about 2 years and 11 months,
Wow.
and they offered me, as long as I could get done by a certain time frame, I could take up a postdoc position here.
Oh, nice.
So,
Right.
I offered a postdoc position here, took that, stayed for 2 years. Then I worked for NASA for, it was actually the European Space Agency for 2 years, but I was based in DC, right?
Right. Yeah.
So I was on SOHO.
Ah,
So I
cool.
was one of the instrument scientists for the SOHO project.
Wow. That's cool.
Uh, did that for a couple of years, and then worked for a different group, but doing more SOHO stuff. And then I came back. My son was born, and we moved back. Decided to move back to Boulder because
Nice.
my wife's family's just 30 miles north of here.
Oh,
So
nice. Cool.
we
Babysitters.
did that. Yeah, yeah. So we did that. I worked for a company called Southwest Research Institute,
Uh-huh.
and then ended up back at NCAR a couple of years later. So
Wow.
so I've been there since 2008.
Nice. That's when I moved out to London. Crazy
It's been a while.
times.
That's
Yeah.
long enough for your accent to be
To get
completely destroyed.
amalgamated. Yeah, yeah. And there's
Yeah,
times like
it's
so
weird.
when
I can hear
when
certain
I
tonal things where I hear very up north, right?
oh yeah, yeah,
It's like a
definitely.
Ross County fan. Yeah.
No.
No?
I always make the
Good.
mistake of going to Tesco when there's a Staggy game and I'm like, damn it. Like, why? However, Mark
It's
Bogan
not a
is
big
a
place.
yeah, Mark Bogan's a Rangers fan and they played them like last week or the week before, I guess.
Not a good game.
And
Not a good game.
no. And I was like, can't make your live because I don't want to say something and you'll be like, you're canceled. So, because I don't like
I'm a
football, I
huge Rangers
prefer
fan,
rugby
so
myself. So it's
right.
I stay away from the football. So I'll support them when it's in Scotland against the world. Then I'll support the football for that because I think it's fun. But yeah, I don't like football or soccer, as you'll call it there.
Yeah, I guess.
So
I try to call it football whenever I can.
yeah, yeah. I always correct people because I fly Mondays and Thursdays, and so yesterday was I 4 hour layover in Heathrow, and then the flight up, and it's like hundreds of Americans on the plane, and I'm just like, here we go, and they're like, oh, I was watching the soccer. I'm like, it's football here. It's football. Don't call it soccer.
It's FITBA.
Yeah. So
Yeah, I know.
he wanted
It's
to
okay.
know about the So in simpler terms, solar maximum and solar minimum for dumb
Right.
people like me. And I always say, dumb
Uh,
it down for me.
all right. So you're going to have to help me here. So solar maximum is exactly what it says on the tin, right? So it's the
Right,
maximum of solar activity, right? So solar activity is all driven by things you don't really experience much on Earth, these big, strong magnetic fields.
right.
Um, and it's interesting. Well, I'm not even going to go down that rabbit hole. But so the magnetic field in the sun produces spots. This is also about the time when there's the most number of spots on the sun.
Yeah.
Interestingly enough, those were characterized by another professor at Glasgow a long, long, long time ago called Wilson,
Ah,
right? And there's an effect that he noticed. It's called the Wilson effect, funnily enough, right?
cool. Mhm.
And it's like when you look at sunspots at the edge of the sun
Uh-huh.
and they look like dimples, but they're not really dimples.
Right.
It's an optical effect. So it
Ah,
was right about the time that they thought they were like clouds and stuff, right?
really?
It's before it's before
Yeah.
they knew that they were magnetic fields. But it's
Right.
an optical effect. So when the sunspot's right at the limb, it makes it look like a dimple, but it's the magnetic field affecting. It's
Right. So like when
it's a
you're
radiative
looking through a
transfer thing.
hydrogen alpha telescope and you just see kind of that swirly bit, that's the magneticness of it, I guess.
Yes.
Yeah.
So Wilson was a pioneer in that stuff. That
Right.
was, I guess, probably close to 200 years ago.
Wow. That's
So,
wild.
so yeah. Anyway, so it's funny because they call it a Wilson depression, and so something small of that would have to be a Wilson anxiety,
Oh,
right?
wow.
So you got scales. No, anyway, sorry.
Yeah, that's cool.
Anyway, so the sun's peppered with these things. They produce violent storms. This is about the peak of it. You know, understanding and predicting when that peak is going to be is um
That's
like
your
pulling the
thing,
runes out of a fire, right? Yeah, allegedly.
baby. But okay, so how did they, in effect, come up with this? Is, I mean, that must have taken a lot if it was like 200 years ago doing that kind of stuff. How did they, in effect, figure out that there's this minimum and
Well,
maximum?
I think there was a bunch of astronomers that in the daytime they had nothing to do, because
Yep.
you know
Like summertime
because
here.
because like when the sun's up, those
Right.
nighttime skies aren't so great, right?
Yeah.
So I mean, there's a joke that most astronomers hate the sun because it cuts down their observing time, right?
Yeah.
So well, it's not a joke, that's reality.
It
But
is true. We shut down the observatory for the summer. So
so they oh well, especially up there. They have so since about the 1600s, folks have been watching the sun with curiosity, right? And they took the very detailed drawings and notes. I mean, you can find Galileo's drawings of the sun and sunspots, right?
ah,
And they took very dedicated notes because they were also messing around with the optics of telescopes,
telescopes, yeah.
right? So there's like, well, we've got this newfangled device. What can we do with it,
Yeah.
right? And so,
So how many blind
like all
scientists
good
were there?
scientists, right? You think? Well, I think most of them they learned to project it by that point. But,
Okay.
but how many astronomers died before
How
that
many did it
happened?
take to figure that one out? Yeah.
Yeah, there's like how many? It's like back to that how many idiots does it take to change a light bulb kind of deal.
Yeah, yeah.
But so I think they observed. I'm trying to remember the sequence of things, but like the Schwabe cycle, so the 11-year cycle was kind of noticed in 1850,
Okay.
right? But that was only about 50 years. So they've been observing sunspots and cataloging since the 1600s. But I think the routine observations started in the early 1800s, right? And that was really done by a bunch of Swiss guys
Uh-huh.
up in the Alps. And in about 1850-ish is when the paper was published that talked about the 11-year sunspot cycle,
Ah.
Like 1859 rings a bell. Don't know off the top of my head.
Right.
And that was where this mysterious cycle was noticed.
Gotcha. And
You
what
know,
exactly
fast
did they
forward another
notice? Like, so was it because they noticed that it seemed to shift, like what they were seeing was shifting, like poles shifting, or what exactly was that?
No, I mean what they were seeing was that if you just did a raw count of the number of these black features on the disk,
Sunspots, yeah.
it would have peaks and troughs that were roughly 11 years apart, right?
Ah,
So trough to trough or peak to peak were roughly 11 years apart, right? And so in the day, this was um, amazing because I honestly think they thought the sun was random, right?
right.
That these
Until
patterns
they
on the
started
sun were
data.
random. So,
Right.
well,
Gotcha.
they captured all this data, but no one and archiving it, but nobody had actually taken the time to
Nobody was looking at all
wait a
of the
minute,
past. Yeah.
which is it took 50 years, right? So
Yeah.
you'd say that it takes 2 or 3 cycles to be able to see that there's a pattern.
Right. Right.
So yeah, so there you go. They basically coined sunspot minimum and sunspot maximum, right?
So is it technically
That's where it
it's
all
not
comes from.
so solar minimum and solar maximum is sunspot minimum, sunset. It's the same thing,
But
basically.
yeah, because if you're worried about the solar wind, of course it doesn't matter, right?
Yeah. Well, for aurora chasers it
And
does.
yeah, but it's the peak time for that is not now. It's
I
a couple
know.
of years from now,
Yeah, yeah.
right?
Right.
So yeah, it's solar activity maximum,
Got it.
but it depends what kind of activity you're worried about, right? So if
Gotcha.
you're operating a satellite up in space, you're worried about charging, so you're worried about the solar wind. You're not really worried about, you know, you're worried about flares and CMEs and things like that, but you're worried
Right.
about
Not
more
as much.
background.
It's more routine for
Yeah,
winds to be right. Gotcha.
so sunspot, you know, and so you know how it is. Things get globbed on, right? So it's sunspot man and sunspot max, but people get sloppy and they call it it's just solar min and solar max.
Yeah, yeah.
And then you have to go through this whole fucking explanation,
I know, because I
right?
kept reading. I was like, so is there a difference here? Now I'm confused. Like, it's
Yeah,
like,
so you got to be careful with the terminology because a lot of times things are very literal in our space. Why
yeah,
is it called a prominence? Do you know?
right.
Because it's prominent against the background sky. That's why.
Ah, yeah, that
And
makes
then, but
sense. Yeah,
on the
yeah,
disc, it's called a filament,
right.
right?
So it's
But
still, so a
but
prominence and
it's
a
the same
filament are the
thing.
same thing. Oh,
They're the
wow.
same thing. Yeah,
I'm,
just
I'm
because
gonna
you see
talk
it
to my
against,
astronomy club today and make them their minds blow.
just because you're looking at it on the disc versus on projection above the limb.
Yeah,
So, and you can get into all kinds of other weird nomenclature where,
yeah,
here's a good one. So there's these objects that you can't really see from the ground called spicules. You can see them from space telescopes.
uh-huh.
Actually, that's not strictly true. That Secchi saw them in like 1877 with his telescope.
Uh,
He
Special.
noticed it was like literally like a prairie grass, right? So it's like
Yeah,
prairie grass. You see these very fine structures in H
right.
alpha
Yeah.
if you've got a big enough telescope, and they're only called spicules if you're looking at them in H alpha, technically.
Really?
If you look at them in any other wavelength, they're called I don't know what,
They're called
right?
something else. Like,
So yeah, we
that's
fought this
funny.
battle about 20 years ago
Right.
because we flew the Hinode spacecraft, and um, the first series of images off of Hinode were absolutely amazing.
Really?
Right, so this is the first high resolution space telescope,
Huh.
right?
Yeah.
And you look at the edge of the sun and it's like seaweed, right? And that's where our first big papers came from,
Oh,
were
wow.
characterizing the motions of the seaweed,
Yeah.
and
Classing them and stuff.
it's fucking amazing. And the speed that the speed that not only was it waving, but the speed at which the material was being shot out
Right. How
was
far out it
spectacular,
was.
right?
Yeah.
How
Yeah.
far, how fast, it was
How
clearly getting heated
immense.
to a
Yeah.
million degrees. Yeah, no, so we actually had to jump in a time machine and go back and look at some of the old
Previous things.
stuff.
Yeah. Wow.
Yeah, no, it was freaking cool, actually.
Yeah. That's awesome. So basically, does NCAR, is that mostly heliophysics, or is it
Oh no,
multiple
no.
facets of?
Um, HAO is about 5% of NCAR.
Okay. So is
So 25% is climate, another 10% is weather, 5% chemistry, 5% helio, 5% tech transfer. There's 8 labs
wow.
and programs,
So
right? And climate's the biggest one.
what's the what's the disconnect in not having more funding for more of the solar research? Because there's a
It was
huge
actually
impact on the planet.
that's where it started from, right? So NCAR was born out of HAO,
Uh-huh.
believe it or not. HAO was first,
Wow.
run by a guy called Walt Roberts, who was a pioneer of solar physics back in the 40s. So during World War II, he was sent to Mountain
Behind you.
just that way in a town called Leadville, just outside a place called Leadville, where lead comes from,
Right.
funnily enough. They had a big lead situation there.
Uh-huh.
Um, Walt was sent there with his wife in the early 40s to try and characterize solar storms because at that point they're starting to figure out that solar eruptions were affecting radio communications during the war,
Hmm.
even though the US wasn't in the war in 1940. So,
They were designing
ish.
certain technology at that time, though.
Well, Marconi and co, that it was a big deal by that point, right? So
Yeah, yeah.
radio comms were a big deal. So Walt was here. He started the first high altitude observatory, which was part of the Harvard College Observatory,
Oh,
because that's where
wow.
Walt was from. So
Wow.
it's connected to Harvard, and a professor there called Don Menzel. And Menzel was a spectroscopist, so he was a astronomer, actually a bit of a genius, and he was into this problem of actually the same one I ended up doing my PhD on, right? So this whole idea of looking at the constituents of the composition of the plasma from the light that you measure.
Uh-huh.
So Menzel wrote a lot of the early stuff on that.
Wow.
And Walt was his student, and he sent a student here with his wife just to live on the top of a mountain
Nice.
and report back when the sun was farting.
What a life, huh?
Yeah, no, I mean,
So
yeah.
is that where the
Anyway,
first
did
HAO
you know that Pearl
was?
Harbor? That's exactly where it was.
Wow. And so now
So
it's in
so it was up in
Mauna.
yeah, they built an observatory on Mount Climax over behind me.
Uh-huh.
And the main eventually it became too large, and so they moved all the infrastructure, all the administration into Boulder.
Uh-huh.
And so that's where it became connected to the University of Colorado.
Ah, gotcha.
Right. This is still long before there was NCAR.
Right.
NCAR doesn't come around till the end of the 60s.
Oh,
Right.
wow.
So there's a long time where HAO was kind of on its own. And then I can't remember the exact provenance, but at some point in time, part of HAO gets split off to become the National Solar Observatory.
Oh,
Right.
wow. Uh-huh.
So NSO was born.
Wow.
Right. And then they built all their stuff down in New Mexico. And yeah, so there was a yeah. Anyway,
Right.
and then Walt Roberts became the first director of NCAR. So NCAR was born out of a national, almost like a National Academy report,
Gotcha.
because weather was so important, but the models and the forecasting of weather was extremely difficult.
Right, right.
So I think it was probably half academic, half national security kind of stuff.
Right. Yeah, that makes
So,
sense.
but this was long after World War II. But so there's not other conflicts around the world at that time.
Yeah.
So they did that, and it's been there ever since. And HAO was the first lab of NCAR, and then the whole place grew up.
Grew up. And so
We have 2 airplanes. We have all kinds of stuff.
I
We
know,
have a mad
I've seen
supercomputer
some of
up
that.
in Wyoming. So
That's pretty
yeah,
cool. But so have people been doing studies of the impact of space weather on terrestrial weather?
very few actually. So a predecessor of mine was a guy called Jack Eddy.
Hmm.
Jack Eddy's pretty famous, right?
Yeah.
He did all kinds of studies about weather and climate, weather and the sun, and back in the 70s and 80s. He was the guy that actually kind of discovered the mono minimum, right?
Ah, right.
So he's the one that discovered that, or at least posited that the mono minimum and the little ice age were connected to one another.
Huh.
So there's a paper in Science from back in the 80s where it was Jack Eddy. So Jack worked at HAO.
Huh.
Right?
Wow. Yeah.
And worked with the climate scientists at NCAR at the time, right? Because
Right.
people were a little bit more open-minded about stuff then. So
Yeah.
don't put that on. I'll get in trouble. But yeah, there's a couple of other folks there, pretty prominent people whose names escape me now, but they were looking at how space weather can affect teleconnections, right? So how large scale weather patterns
Uh-huh.
were the result of, or were at least impacted by solar radiation, things like
Right.
that, right?
Right.
So it's not dead, but if you look into the guts of all of the climate models right now, all they use is the spectral irradiance,
Right.
right? So they use irradiance.
Yeah.
And
So
it doesn't vary very much.
gotcha.
So to them, I gave my old boss some shit yesterday. I was like, to them, it's a solar constant, right? It doesn't
Yeah.
really matter to them because all you need is enough watts per square meter to kick the weather off. That's what they
Right.
will argue, right? But I said, no, I think you probably need to figure out, what's going on. And I think it's a lot more devious than, because we can see, for example, we can see, we haven't even talked about the Terminator, but we can see
We're getting there.
patterns of the hale cycle associated with ENSO, right? So the El Nino solar oscillation.
Yeah.
Sorry, southern oscillation.
Yeah.
Freudian slip, right?
Right.
ENSO, and it's kind of interesting, right? Because the Pacific Ocean is a huge detector, right? It's the biggest
Massive.
continuous mass of water.
Mm-hmm.
So I always refer to it as a big detector, right? Because I'm dumb. And so if you're looking for a weak signal of something,
Mm-hmm.
you go to the place where you have the biggest detector,
Yeah.
right?
Yeah.
Yeah, it's like we didn't see gravitational waves until we built an adequately sensitive detector. We knew they were there. In fact, you can go to Glasgow Uni and see the original gravity wave detector, right?
Yeah.
But it was just building something big enough and sensitive enough to be able to measure them.
Right.
So, so the Pacific actually shows a fairly strong correlation with the hale cycle.
Oh, wow. So do you have
But
like sensors and stuff in the Pacific Ocean, or do you do it from satellite?
yeah, they measure. Dude, they've been measuring that. They've been measuring the temperatures of the Pacific Ocean since the 1700s.
Oh, wow. That's
Right.
crazy.
So all of those mad colonialization
Yeah.
trips that the British Admiralty undertook.
Uh-huh. Solomon's Island and all that stuff.
There's logs of James Cook seeing the aurora over Hawaii, right?
Oh, wow. Huh.
So actually, it's one of the things I want to do if I ever have time is to go and look through the Admiralty records to see if I can build up a catalog of low latitude aurora.
Yeah, that'd be cool.
Right?
I'll do the
I'm
research for you.
deviously
I'll do
I'm
that for you.
deviously interested in those. Yeah, no,
That'd be cool.
very.
Given my sailing background, because everyone's like, "Oh, don't go to the Pacific. It's a lot more difficult than you think." And I was like, "I don't even want to go over the Atlantic, mate. It's cool. I'm a coastal sailor. I'm not a long distance sailor."
No, you gotta be a maniac for that stuff.
Well, yeah, this
But
one dude from Norway to Shetland in the middle of force 7 freaking winds. I was like, "Yeah, you got some cojones, mate," because I would never do.
uh, pretty sure that guy's related to Vikings.
He's Norwegian, so yeah, he definitely
Yeah, he's
is.
like
His name
they're
is
giving us
Hans.
some mad Viking. Yeah,
Yeah, with his brother Lars. Like,
right. It's half of Metallica right there.
yeah,
But anyway,
exactly. So the
but yeah, no,
Terminator. Do you guys have a
yeah.
betting pool on whether you're going to be right on the Terminator or?
With the next one,
Yeah, yeah, yeah. So your prediction of
uh,
the Terminator. Do you guys have a pool that you do to see if you're right?
no, I mean the first thing was proving that they were real.
Yeah, true.
Nobody believed they were real, right? And in fact, I think if you pulled 95% of the solar physics community, go, what are you talking about?
Right. So define what the Terminator is, because I know Mark doesn't know what that is. So he'll be like, "What are you
All
talking
right,
about?"
so underlying this sunspot min and sunspot max stuff, the sun has a 22-year magnetic cycle, right? So the sun's
So,
magnetic fields go through one complete oscillation of positive and negative in 22 years,
uh-huh.
right? Positive, negative, positive. So that whole cycle takes 22 years. Um, wow, it's hard without a picture. But
Well, yeah. I mean, I've showed him the pictures. I like shared your tweets and stuff because I was like, this might help you. Probably not, make give you
yeah,
more questions, but at least you can understand what he's talking about when he says the Terminator. So,
yeah. So you have this 22-year cycle, and the magnetic field basically trundles from polar regions down to the equator over the space of about 19 years.
mhm.
We were able to see this clearly in observations, finally. But when it reaches the equator, something happens, right? So the one from the system from the northern hemisphere and the system from the southern hemisphere meet at the equator, then all of a sudden, poof.
It flips the color because you have
It
it's red
literally,
and blue
it,
that you use, and yeah, so you
yeah,
see the shift
it
in color.
literally, it literally disappears,
Yeah, so
right?
it's just like a defined line of nothing there.
And when it disappears is identically when sunspots appear at mid solar latitudes, right? So there's this weird thing. When was that? 2011. I literally had the bathtub moment, right? I mean, literally the bathtub moment.
Right.
And I'm sitting there because I'm looking at all this data, and there's something really fishy going on because we were basically looking at how the hale cycle and we didn't call it that at the time. We didn't even really know that it was the hale cycle, but we were looking at the fact that even though we were in sunspot minimum, right, but we were seeing these very definitive bands of features in the data, right? It's like they shouldn't be there unless there's something in the background, right?
Right. Right.
So now when I go back and look at the data, you can see 6 years where there's clearly four systems right around the equator, and they all merge. Well, they don't all merge, but the
Right.
higher latitude ones are there, and the little ones near the equator move in, and then poof. Then all of a sudden you get sunspots on the ones at mid latitudes, and you're like, holy shit, what's going on?
Uh-huh.
And I don't know how it ended up being called the Terminator. I think it was just the terminal point of the hale cycle.
Right, right.
right? It just ends. I mean, one of the things, Lisa, is if you deal with a lot of features on the sun and a lot of the physics of the sun and a lot of the calculations that are done about the inside of the sun, they imply that the sun is a very diffusive thing, right?
Yeah,
So what I mean by that, you know what that means, right?
yeah.
Is that like it
It's
nothing really happens instantaneously,
right.
right?
It's like a build
It's
up, like everything.
it's
Yeah.
it's like syrup. It's like
It's
pouring
like those
syrup off your
science
spoon.
experiments that it's just like oozing out. Yeah.
Yeah, and so, well, other than in the upper atmosphere, that's not true because you can get catastrophic breakdowns of things, right?
Uh-huh.
But in the inside, the idea is it's so viscid,
Yeah.
right? That you can't have things happening like that.
Right.
And,
Yeah.
and yet, and yet, when these magnetic fields at the equator disappear, within one rotation, you all of a sudden have a complete change in the sun's magnetism, right?
Right.
And then you start to ask yourself some really tough questions, right? Because you're like, first one being, how the fuck does that work?
Yeah. What impact does that have on
The
us?
second one is, who the fuck's going to believe me,
Yeah.
right? And so basically, you had this bathtub moment back in 2011 where I said, holy shit, this this is the trigger for the sunspot cycle, right?
Right. Right.
And you're getting into this thing that, well, really, we've known about the coexistence of the hale cycle and the sunspot cycle since Hale discovered the Hale cycle, right? For
Right.
100 years, right? But not how they actually work together,
Right.
right? Right? It's subtle, right? So
Yeah.
we know they're there. We know they're coincident in space and time, but we don't know how one drives the other.
Right. Right.
I would argue now we do,
Right.
right?
You see
So
that correlation. Yeah.
it's a fundamental thing, right?
Yeah. Yeah. Yeah.
And so then you get to this point where, okay, now the sunspot cycle is an interference pattern. It's actually not the fundamental thing. The Hale
Right.
cycle is.
It's a symptom, basically. Yeah.
And yeah, and then you start to get into a lot of trouble, right? Because now
Right.
you're jumping to the inference thing where all of our modeling of things like the sunspot cycle are kind of wrong because they're looking at it as the fundamental thing in the system,
Rather than
but
a
the system's doing
reaction. Yeah.
other. Right, exactly. It's exactly a symptom, right?
Got it. Yeah. So now that you've pretty much defined that aspect, what's the next step for what 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 thing do you need to look into to further that information and get
Well, I
more?
mean, we know, you know, in 2018, 2019, we were playing this game of trying to figure out what Sunspot Cycle 25 was going to look like, right?
Yeah.
And we noticed that there was a very strong correlation between the separation of these Terminator events
Uh-huh.
and what comes next. Because if it's a big interference pattern, and this is really hard to show without a picture, the amount of time by which one Terminator eats into the next Hale cycle
Uh-huh.
really plays havoc with the amount of time the sunspot cycle can grow, right?
Ah. So it
Uh,
makes it longer or shorter? Gotcha.
Bingo, right?
So that's like your
And
9 to 11 years, like you're not
well,
sure which.
the slop, the fact that the sunspot cycle is sloppy is exactly because of the Terminator, right?
Gotcha.
Right, and so you now have to ask yourself what physical mechanism can speed up and slow down the Hale cycle,
Hmm.
right? So that's the key to understanding why it's not always just 11 years, right?
Right.
Because if the Hale cycle didn't stop, the Hale cycle seems to be driven by just basic geometry of the sun, right?
Right.
So the
Right.
geometry of the sun shapes the Hale cycle.
Got
The rotation of the sun shapes the Hale cycle.
So there are
The
exterior things to the sun that would affect it. I mean,
no,
not
no.
like
Well, I mean, there's a whole chain of
could it
theories
be
out there.
aliens?
I'm not saying it's aliens, but
And
it
you're
could
not
be.
saying it's not aliens either.
That's not aliens.
I'm just kidding.
Yeah, I know, but
Wait.
it's kind of interesting, right? So the average sunspot cycle length is like out of 10.86 years, right?
Yeah.
Something like that. Um, the fun bit with that is what's the orbital period of Jupiter?
I don't know. You're asking me
10.86 years, right?
how much? Sorry.
10.86 years.
Okay. So there's an
So
impact.
there's a chain of thought
Uh-huh.
where the sun's internal sloshing, let's call it that, for the lack of a better term,
Hmm.
is being tidally affected by the gas giant planets.
That makes sense.
Right?
Yeah.
So it does, except for the fact you're worried about a magnetic field and not just sloshing, right? So if it was like the tides on the Earth, then I could see it,
Yeah,
right?
yeah, yeah. Right.
But the amount of energy
It would
provided
have to
from
have.
Jupiter and Saturn to the
Yeah.
sun is
Eh,
insignificant compared to that the other way around, right?
gotcha. Yeah.
And to make that a wee bit more sneaky, the how do I do this? So, well, there's this whole problem with the magnetic field, but you've also got this problem that the gas giants and all the planets really, I mean, they contribute gravitationally, but do they contribute to create the drumbeat of the
The sun.
sunspot cycle?
Yeah.
Right?
Yeah.
But when are they in conjunction? Right? So in order for it to work, you'd have all these random patterns flying around, right?
Yeah. Yeah. Yeah.
You'd be able to pick out Mercury's signature. You'd be able to pick out Venus's signature. You'd be able to pick out,
Right.
so if you looked at 400 years of data and you did a harmonic analysis, you do this shit, right? You would
Right.
see that, oh, look, every blah, 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 blah. And here, every 15 years is a conjunction.
So
And so
you're
they're
looking at
all pulling in the same direction.
right. So you're looking at like their spectral signature to define. Oh wow.
Right?
Yeah.
But you don't see that, right? You don't see that. So it's very hard. So the energy density of the sun's rotation is incredibly massive.
Yeah.
So even if there was a tidal force, the rotation of the star kills it,
Right.
right? So it's like, 1 part in 10,000 kind of deal, right?
Yeah.
So the other 9,999 is way higher than that one.
Yeah. Yeah.
So anyway, not saying that there's not a pattern in there, but
But there's,
there
so it's
may well
probably
be.
just a small part of the formula.
Yeah, I'm not saying it's aliens, right?
Tiny.
Not saying it's aliens.
It's a ray gun, an alien's ray gun.
Yeah, right.
Really big ray
So,
gun.
but
Bigger than a
it's kind of
million
cool.
Earths.
It's. I remember having some very interesting conversations with folks back in 2011 when I was trying to figure this out
Hmm.
because I knew this fact, right? Like it's a fact. It's a fact. It's well
Yeah.
known what Jupiter's orbital period is, right?
Yeah.
Uh, and I just couldn't. I couldn't. They did some back of the envelope calculations. There's no way. Jupiter's huge, but there's no way you can get it always working in the right direction compared. Because what we figured out really quickly, Lisa, is that it's the rotation that's important.
Yeah.
So this is all about the whole thing is set up by basic characteristics of the sun. There's no mumbo jumbo, right?
Right. Yeah. It's
So it's
facts.
like you'll see my stupid Twitter posts about why 55 degrees is important. That's
Your
my
thing.
bugaboo.
Yeah.
Yeah, that could easily be my Moby Dick right there. Right?
All right,
That
Ahab. That's your name
Yeah,
now.
no, but that could be my 55 degrees could be my Moby Dick because
Okay.
that's where it happens, right?
Right.
That's where the magic is. There's no magic at the mid latitudes because that's where all the solar physics models are kind of wrong. They because that's where sunspots appear. They've invoked magic physics there, so it's like bagpipe playing unicorns floating across the glands, right? Yeah, it's like, oh, that's where they appear. So, but the problem is, it's not the same latitude all the time,
Right.
right? It's one cycle it's 30 degrees, one it's
Yeah.
38
Yeah.
degrees.
Yeah.
It's
It's
like
like,
so somehow the magic also moves around. Oh, it's like
uh-huh.
Outlander. Wait a minute, yeah.
Got it.
So that doesn't work. That shit doesn't work, right?
So maybe it's
You
like
can't come up with
DNA where it's doing
a
a thing.
or maybe it's just the Hale cycle and the sunspots appear just where the Hale cycle happens to be, right?
Yeah. Yeah. Yeah.
So where the Terminator happens and where the mid latitude band is exactly where that sets the latitude when the sunspots appears. There's no mumbo
Huh.
jumbo, right?
Right. Right.
It's not about peaks in the rotation. They've got some very exotic dials to twist in these models, right?
Yeah. Yeah.
So anyway, so that's there's your so
Your
the like
basic knowledge.
geometry. Yeah, I know. But what's really beautiful is the geometry that sets it all up,
Yeah.
right?
Yeah.
I think when you're a physicist and you figure out that something is really set by fundamental characteristics.
Hmm.
We start to float the word elegant around. That's when you start to hear the word elegant, right?
Yeah.
Because
Yeah.
it's like, fuck, that's really simple,
Yeah.
right? You've kind of broken it down to the basic things. I'm sure
Right.
the microphysics is not fucking simple,
Yeah. But
but
that's not your thing. You're like,
the macro physics is really looks simple.
yeah. Yeah.
So our next one is okay. When's the next Terminator going to be?
Right.
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 So I'll tell you. I'll tell you in 4 years.
Okay. I'll be waiting.
Yeah. No. I mean, literally, we should be able to track the next hail cycle by the middle of next year.
Cool. Very cool.
And then once we see that, we can project. We'll know things like when the first sunspots of Sunspot Cycle 26 are going to appear. In fact, we published that in 2014.
Wow.
Not that anybody was really paying attention,
Right.
right?
The
But we
more
were
the more
right.
tumultuous storms and stuff that happen, then people are like, oh, you know what? The sun needs looking at. It's kind of like aurora
Well, it is.
chasers. Suddenly there's a load of them because it's it's solar maximum. It's gonna be
Yeah,
grand now. We should all go chasing. And I'm like, don't be so eager.
yeah, but you've got a couple of years yet before those fade. It's just
Yeah.
you get this unfortunate thing living closer to the poles that that
Yeah.
stupid sun. And
Magnetically we're
the other
quite
part,
in there. Yeah. But no, we do. I have a lot of friends who come up from down south who are like, oh, I'm gonna come up and visit you and see the aurora. And I'm like, all right, well, make sure you check the weather report first. Like, what do you mean? I'm like, well, you can't see them through the storm clouds. So have fun with that. And
yeah,
inevitably
I know.
everyone comes up when there's a storm. And I'm like, and it's not the right storm, guys. Like, and
Yeah,
2 days
yeah,
later
wrong
they
one.
go and oh, there's aurora. Sorry about your luck. But
Yeah, no, it's funny that way, isn't it?
yeah.
I remember being on the Rannoch Moor when I was working in Aberdeen and I was driving home.
Uh-huh.
This is before I moved to the US. Uh, and I can't remember what I did, but in my rearview mirror, I saw the Northern Lights, and
Uh
I stopped
yeah.
and I
It's the
pulled.
most
And like,
amazing thing.
holy! It was February, I think,
Yeah,
and
best
and it
time to
was one of
see
the
it.
coldest fucking nights I can remember.
Those are the
The,
best ones because the air is so crisp and the scintillation is
eh,
amazing.
the clear sky, clear skies.
Yeah,
And I don't even remember why we were driving at that time. And I looked in the rearview mirror, and this like that right behind me was just lit up, and I'm like,
yeah,
holy crap! I was trying to remember when that was. Well, that would have been. I was trying to remember because it was a bit would be. So I came over here in '99. I gave up that job in '96 because once I started my PhD, I didn't have time to work
Yeah.
other than being paid peanuts to do stuff.
Yeah, yeah.
Um, so maybe been about 94.
Wow.
So 94, 95 kind of area. So anyway, long before I was interested in this stuff.
Yeah.
But I vividly remember like, holy shit. So anyway,
Yeah, a
totally
couple
off
months
course.
ago I was up Loch Fleet because it's really nice and dark up there, and I was there for hours, and I was just like, I gotta go home because I gotta go to work in the morning, and it's like 2:30 in the morning, and I did that a lot. And I was driving just coming up over towards Dornoch, and I was like looked in the side view mirror, and I was like, I gotta stop. And I just started
Yeah,
this like
right.
wing mirror thing because it was like wing mirror, loads of aurora, and aurora on the other side. And I was just like, yeah, you're never gonna have this opportunity again, so just go for it. And then my mate,
No, my
go ahead.
sorry, go on.
No, my
No,
mate
I
who
think
lives up
Dornoch's
there, she
Dornoch's so
has
beautiful.
it's
Yeah.
gorgeous. I'm gonna actually get a property. My friend and I were talking about that today. She's like, "Oh yeah, you could have it for the winter. You could chase up there and rent it out in the summer." And I was like, oh, "Actually, that's a really good idea because then I could just pay for everything with that because the summertime hires are ridiculously expensive for people. So I could put it
Yeah.
down just a little bit and still be making a good amount of money." But yeah,
No,
and
I
she
mean it's beautiful up there. I was a big golfer, so
golf
I
club stuff.
played at Royal. I played at Royal Dornoch a couple of times. It's just
Uh,
gorgeous,
yeah,
so
yeah. I
peaceful.
golfed a lot when I was in South Carolina because when I was in the Air Force, that was like the way to get out of work on Fridays is go play golf. And I was like, I don't know how to golf. It's like, oh, we'll teach you. And so they took me to the driving range and I was like, all right, what do I do? How do I hold the club? And they're showing me. And I hit straight just naturally. I hit straight and they're like, right, we're not going to teach you anything. I said, well, I don't know what clubs to use. And they're like, we'll tell you what club. And I was like, okay.
Yeah, just hit them.
So
No,
you
it's
did like
that's
best
cool.
ball and that stuff.
It's some beautiful courses there. I played there
Yeah.
several times when I was a junior, so played a
Well,
lot of golf.
I lived right near Kiowa, so
Okay,
we
oh yeah, it's not bad.
yeah, it's nice. And they always had so for the cup, was it the America or whatever,
The
the
Ryder Cup,
Ryder Cup,
the
that's it.
Ryder
We
Cup.
used to get farmed out as military detail to do the parking and stuff. And the guys always loved it because they're
Okay.
like, yeah, we're going. And I was like, I don't want to work in a damn car park. Like, get out of here. I'm staying home. They're like, well, you
Bad
have to work.
attitude.
And I'm like, good, I'll work. Because I didn't really care. But
You could take your bad attitude and go home. Yeah.
yeah,
No,
they're like, yeah, off you go back to the
I never
flight
played
line then.
never played at Kiowa, but Pinehurst. Played at Pinehurst and
Yeah.
a bunch of the we did a tour over there when I was like 15, 16.
Oh, yeah.
So Scottish junior team went over there and played. So
Nice, nice. I remember I was at St. Andrews and I was walking around the cathedral there, and there was an American
yeah.
couple there with their daughter who's gone to university there. And they said to the tour guide, because I was just walking around and I heard them and I was like, oh, avoid them. They've got American accents. And and I heard a guy go, oh, they have golf in Scotland. And I was like, fuck off. He's like, and the woman who was giving the tour, she's like rolling her eyes, but
Just offended. Just offended. It's when you wheel out that Robin Williams skit about the origins of golf. It's like you just don't know, right? So
yeah.
I love St Andrews. I actually turned down a golf scholarship at St Andrews. So
Really? Wow.
yeah,
But
I didn't like the physics department, believe it or not.
nice one. You got to get
So I
along with
turned,
them.
and if you're from Glasgow, St Andrews is a little bit different, right? So
Yeah.
even if I look at it back, kind of myopic thing to do is to turn down a chance to play golf there every day and represent the school and all that stuff and
Right.
become a pro, whatever.
Yeah.
Decided I
Not all
didn't
it's
like the
cracked up to
physics.
be.
I didn't like the physics department was my thing. Like,
The claim
what?
to fame there, you know? Where would you be
What?
now if you'd have gone there, though?
Wow, it's
Probably
barely
not.
famous now, so it doesn't matter. Could have at least gone on the tour with some of my friends. A few of my
Right.
friends played on the European tour for years, so
Ah, yes. Name dropped yet? No.
yeah.
It's like,
So yeah, but yeah, no, it's been a weird one. The pathway's been strange because ever since we made that discovery, kind of like I always make a joke with people about, you've seen the old Costner movie JFK, right?
yeah.
Where they talk about going through the looking glass.
Yes. Uh-huh.
That's what it feels like. It's like,
God.
holy shit. It's like all of a sudden you've got X-ray glasses on and you can see
Hmm.
what's going on, right?
Yeah, yeah.
And everybody else is still like clutching, groping in the
Yeah.
dark, and
But
you're
you
like,
know what that
no.
picture, what's the picture of the person that's in like a glow? It's kind of like a cartoony. I have a friend who's a retired CEO in Arizona. And he always says because I always contact him about like advice and mentoring for work and
Uh-huh.
stuff. And he always sends me that picture and he's like, you're in the dome because the person's head is looking out. And he's like, get out of the dome, look out of the dome. Because it's kind of like that reset of you're stuck in the minutia, like look out, get
Yeah,
your 360. And so I've always
yeah.
loved that because it's like, okay, yeah, yeah. So I have the picture. like,
No,
keep,
it's
uh,
I always come at stuff with a very open mind now, right? So not that I was very close-minded to begin with. I've done so many things between
yeah.
football and golf, and getting into this stuff was the last thing I anticipated, right?
Yeah,
So
yeah. But it's quite
so
exciting. So are there any new things coming up as far as like studying the sun and the heliophysics world that is like exciting stuff that might help further the cause, or is it still kind of hard to get funding for things to happen?
well, I mean, we've not had a single dime to pursue the work that we are on, right?
Have one good event happen to the world, I bet you start seeing money, but it sucks
Well,
that
I mean,
that's what
the,
it
the
is.
community gets a fair amount of money, but for whatever reason, the gatekeepers are keeping us away, right?
Uh,
Right.
is that part of the alien thing then?
I don't know. I think it's you grew up here, so probably read Upton Sinclair, right? The Jungle.
Yeah,
You basically, if someone's livelihood depends on it, you're never going to convince them otherwise, right?
yeah, yeah.
I think there's a lot of that bullshit going on. I think they feel that we are, well, observers effectively,
Right, right,
and because we're observers, we're not smart enough to figure out how it works.
right. Of course.
You know,
Under,
unbeknownst to them, that all of science is driven by observation. But other than
right.
that, you know,
Well, it's like
um,
that the stuff that the is it James Webb Telescope that found stuff that's blowing some of the physics stuff out of the water, and it's like, well, why are you surprised? Like, I mean,
yeah, but yeah, it's the Big Bang theory. It's questioning, right? It's the
yeah, yeah.
universal expansion. Yeah, 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 yeah.
And I
No, but
think, yeah, because I'm
of
like, why
course.
wouldn't you stay in question? That's the whole premise of science, isn't it?
Well,
Like,
but the problem is, Lisa, you've got 75 years of thinking one way.
yeah, yeah,
And in the mid 80s, early 90s, when early supercomputing came along,
yeah,
the whole character of what goes on inside the sun changed to a point where they think that they can just model it, right? And this is where we noticed the difference. So there used to be a whole bunch of ideas out there about how it worked,
yeah,
but within a few years of doing these first calculations, the number of ideas shrunk to two. and those two were the same, basically. And so, but what that means is that those two groups are the only ones that were approved to do that work, right?
Right,
And
right.
so if you were pushing on them from the outside, they just shut you down.
Yeah.
So if you look at the history of or the what's the right word, diaspora, or you like it's like a
Diaspora, yeah.
family of things. Everything dies off except the two species,
Right, right.
but
So
nobody's even
survival of the
looking at
fittest kind of thing.
nobody's even looking for the pygmy in the forest anymore, right?
Yeah. Even though it's
Right? Nobody,
have a whole
it's
family
there.
going on there.
Well,
Yeah.
well, I think the problem is that we can point to it,
Hmm.
right? We can go, look, there it is. Oh, look, there's an event that happened. Oh, and all of a sudden you get sunspots. Oh, but you're just cherry picking.
Yeah.
Oh, yeah. One event.
Just
All
cherry.
right. Well, go find more. Okay, here's 14.
Yeah, yeah. We're like,
Oh, no, no, no,
oh
no.
no, we need
You're
at
just,
least
no.
50 to 100.
Well, here's 24, right?
Yeah,
And better than that, I can tell you when the next fucking one's going to be.
yeah. How dare you?
So tell me you've got more skill than I have, right?
Yeah, right.
And so, I think that maybe by the next time, because I think it's still considered it's just luck, right? If you talk to people, they'll go, "It's just luck." I say, I don't think it's luck
Yeah,
because
kind of
there's too
like,
many other. The problem is there's too many ancillary pieces that connect,
right.
right? So it's kind of like the Rosetta Stone. Before that, you had no idea how to interpret the hieroglyphs.
Yeah, yeah.
But just that little bit of insight then allows you to grow your vocabulary, right?
Yeah, yeah, expand things.
Hmm? Good luck. Just give me a call afterwards. Good luck. Look great. Um, so it's kind of like you find the Rosetta Stone, helps you interpret the hieroglyphs, and then all of a sudden things, you can extract volumes from the scripts, right? It's
Right,
like,
right.
ah. So anyway, so we are not allowed. We don't play up too much. We've never won a cent of funding for this work,
Yeah.
so we just keep going. We're just going to keep bludgeoning them, right? Just point out the obvious,
So do you ever
and
get
and eventually,
threatened with
well,
getting shut down, or is it no?
no,
That's good.
because they've already done everything they can.
Cool.
So they basically, every paper that we write takes 2 years to publish,
Yeah.
right? Because the gatekeepers in that world try to either stop it or slow it down. It
Yeah.
became almost impossible to publish results.
Wow.
And then when you're going through peer review for proposals, invariably your main competition is reviewing your proposals. So, but it's the same with papers, right? But
Yeah.
we've figured out a pathway to be able to get stuff out through publications, but proposals are much harder, right?
Right.
So they think they starve you of publications and proposals, then you're going to die.
Right. Gotcha.
So like my colleague Bob Lehman hasn't. I'm okay because my day job is not connected directly to science, right? I
Got it.
run the place,
Yeah. Yeah.
right?
So you've got that
So
behind you.
I'm paid to run the place,
Yeah.
but so I'm not dependent on those grants. So I basically do stuff in my spare time, right?
Got it. Yeah.
He's not as lucky as me,
Ah,
right? So it
yeah.
impacts him because
It's his bread and
it
butter.
hasn't deterred him though, right? It
Yeah.
hasn't deterred him though.
And that's good. He's got the
But I think
passion.
eventually we're going to be proven to be correct.
Yeah.
But
And
it's how
that's good.
long? It's yeah, but the uptons and clearness of it all is very strong. Believe me,
Yeah.
right? The cognitive dissonance machine is very strong.
Yeah. I ran into that
I
at
think the first.
MIT for sure. Like,
Oh shit! I bet.
yeah, I was like an admin for research we were doing on the effects of frequency and vibration on cancerous tumor. And it was a double-blind study, so we didn't like none of us corroborated with each other. I just ran the CSV files and helped make it look pretty into a graph and stuff. And the professor who was on it with us, he said, look, if we get really good results, don't be surprised if we get shut down because it's just the nature of the beast, you know. They can't get rich off of healthy people. So, and we started getting really phenomenal results, and I was just like, oh, this is so cool, you know, and it's this to me exciting, and to even just have a little part in it. And then they shut us down. I was like miraculously we get a 500,000 pound or dollar donation from an undisclosed company. It's like, oh, okay, yeah, I got it, never mind. So yeah, you see.
No, but this shit happens all the time, and
Yeah,
throttling the funding to control the work. And yeah, there's probably all kinds of very promising technologies in that space, right? So
yeah.
the thing I worked on in medical physics was about stroke imaging, right? So when I was doing my medical physics stuff,
Uh-huh.
although I eventually wanted to get into radiation oncology, what we were working on was tuning the MRI machines to the diffusion timescale of water, right?
Ah.
So the idea is like, because we're working on the brain, and strokes are all to do with excess fluid, right? And so what we were actually trying to do was really weird. So if you tune the machine, image all the water in the brain, and then the idea is you do what we now call local correlation tracking. And the idea is you try and track the little parcels of fluid
Fluid, yeah.
to see if they were all moving in the same direction,
Oh
right? Or
wow.
if they were going
Yeah,
towards a
yeah.
point. And shock horror, where they were converging was the stroke source, the stroke site,
Ha.
right?
All right.
So it was a completely experimental at the time, but now it's standard practice. So,
Wow.
you know, so no, that was
Amazing.
super cool. It might be one of my first papers actually
Wow.
ever doing
Yeah.
that. So
So you
that
have
was
like
pretty cool experiment.
151 publications. I was like, all right, yeah, just a bit of a writer there, are you?
I know I fucking hate writing, which is the really interesting bit. So I'm
Yeah,
dyslexic,
but you
so
love
I
doing the
fucking hate it.
sciencey stuff. I mean, so like it's you got to take the good with the bad, right? It's like,
Yeah, I mean, this is the vehicle by which you communicate, right?
yeah,
So,
yeah, yeah.
at some point, I've left Easter eggs in a lot of my papers for
Oh, cool.
people, right? So I have a bit of fun with it,
That's good.
There's,
Yeah, that's always good.
but it's hard. Writing is tough.
Yeah, it's
I
yeah.
hate writing. I've got to write a book, actually. Um, I'm working on writing a book about solar variability.
Oh, cool. Good. So
Yeah,
are you still gonna be teaching at the week long thingy? I don't know. I didn't see. No.
no,
Oh, you
no.
got on the bad
So
side? No.
no, Tamitha and I have spoken about it. Don't worry, she
Yeah,
doesn't hate
no.
me too much. Um, no, but I'm providing the lectures and the script for the lectures.
Ah,
Just one
okay.
of my colleagues here is going to do it.
Oh, okay, cool.
Um, and I'm still trying to convince him to, like, if there's Q&A, to hook me in, and we'll do a Zoom.
Oh, that's cool, yeah.
For whatever reason they don't want to do it.
Ah,
So, well, I
nice.
knew for a fact they wouldn't let me present remotely,
Right.
but I mean, even just doing a Q&A. So I'm going to give 2 hours of lectures through someone else. You could at least then do a Q&A with the folks so that they want to ask me questions. They
Yeah.
can, right? But no, they don't seem to want to do it. So
That's weird.
I can be available at any point in the week to cause trouble, right? So I just can't. The problem is not actually being there. The problem's the travel.
Yeah, yeah, yeah.
I've got a commitment at the start of the week and a commitment at the end of the week.
Yeah.
And the one at the start of the week came up. It's like my
Your nephew, is it?
Hard to say.
Or godson?
It's a kid. It's a yeah.
Yeah.
It's not something I can tell to go
No,
fuck
that's
off,
important.
right?
No, I don't ding you for that. Because I said to Tabitha, I think his
So
reasoning is good, so don't don't give him too much shit. But I said, but we
no,
will
I
give
mean
him
I give
shit.
myself. No, that's fine. That's I give
I'll be
myself
like
shit too, right? Because
tweeting,
I'm
like, oh, look at that beautiful. Ah,
yeah.
sucks
You
to
rub
be
my
you.
nose in
No,
it. Thanks. Yeah, no.
Salvig. I'm
And that meant that I couldn't travel until right. So that's on the 11th. Couldn't travel to the 12th. So it means that the earliest I could get in there is the 13th.
Yep.
And the 12th is also Mother's Day. And so like
All
my wife's
right.
like,
Oh, that's why my son forgot Mother's Day here, because I did make a deal with him. He could, because he wouldn't be
he
able to
does the
get
US.
reminded by the hallmarks in America. Like, it's like, it's just another day. I don't care. Like,
Yeah, I know. I mean, my wife's generally very chill about it, but it's
yeah.
like, it's so,
Yeah, you don't want to
I would
not
get
be
into,
there for
I'd get,
that. That'd be just bad.
well, no, but I'd get into Rome. I'd get into Rome on the 13th at about noon.
Late.
And then I'd have to get there, which is another God knows
Another
how
hour
long
and
on a
40
bus.
minutes, I think. Yeah.
Yeah, and then do all that, get off a plane and give 2 lectures back to back,
Yeah.
and then turn around a day and a half later.
And be toast for your next event. Yeah.
No, well,
Not a good
the one
look.
on the other side's the other one on the other side's my daughter's graduation, right?
Oh
So,
well. Yeah, you can't miss that. You'll be in the shit
so
streak for sure.
and what, it didn't really dawn. So the invite to the godsons was late,
Yeah, yeah.
but it didn't dawn on me till I started putting things on the calendar and I'm like, fuck.
Ooh, I missed something. Like, yeah. I
Yeah,
do
and I
that
can't.
because
But if it was here, it'd be easy.
oh yeah. Yeah,
If
yeah.
if it wasn't,
So this is the thing
seven
then
thousand
you just
miles
have
away.
to create one that's in Boulder. Just do another one.
Yeah,
Like,
we could we could
like
do something similar. I mean, we don't have. I mean, the backdrop in that place is insane.
I know.
That's going to be incredible.
I know.
I'm
I was
actually
just
really
like,
jealous. I don't.
because I just got my cast off from having a fractured metatarsal, stupid thing. But
Yeah,
and yeah, so I was at physio this morning and he's like, oh yeah, we're gonna have to fit you for this orthopedic. And I said, all right, like okay, don't tell me all that stuff. So when can I walk like normal? And he's like, oh, you
right.
gotta be careful because you could easily refracture it. And I was like, so you're not telling me the answer here, mate. I was like, I'm gonna be going to Italy in 3 weeks' time. Will I be able to walk? He's like, possibly. So I'll let you know next week how things go. I was like, I do not
Oh, good
like to
luck.
not be moving around, but I'll bring my
Yeah, next
camera.
week I'll do. I've got to build my lectures next week, so because I've got to spend a bit of time with the person that's doing them and bribe them sufficiently.
Yeah, yeah, yeah.
So Tom Berger's doing mine, and I know Tom, but I'm going to give him stuff, but I'm not giving him all the secret sauce. So,
Yeah. Well, it's like
um,
the Millersville stuff that Tamitha does. I took that and I'm one of those people that I've got to print out all the stuff and I got her permission to print out all the slides and stuff and I have it in a book and I was like, we need to talk about a proper textbook for you because
well, one of the things I talked to Rich Clark at Millersville.
uh-huh.
I know Rich really well.
Didn't he retire or
Uh,
he's yeah,
yeah,
yeah.
he retired. And I was originally, at some point, I'm supposed to teach this class on solar variability as part of this
The
thing,
program.
right?
Yeah.
Yeah, and I'm like, well, that would actually be good because if I did it over a series of 12 lectures, that would force me to write the 12 chapters of my book.
There you go. Yeah.
And then, and then, and then, you know, That's how I was going to do it. Was just basically develop a chapter per lecture,
Hmm.
and because I said, if I did this, it would actually force me to dedicate the time to do it because my
Yeah.
job is like ridiculous. My job is stupid.
I imagine you
So,
get
but hopefully my
managing
job is
chaos.
changing. My job is changing soon. So hopefully I'll give a lot more time on my hands. So
Ah, changing as in you won't be the deputy director at NCAR. Okay. I won't ask
yeah,
further.
no, soon enough. Probably
Still
by
in
the
Boulder
probably
though, yeah. Or
yeah,
that's
probably
good.
by the fall.
Right.
So no, it'll be good. I'll have a lot more time to do stuff that's of interest to space weather and things like that. So
That's cool. Yeah, very
who
cool.
knows? I may be doing that with people like Tamitha. So
Yeah, that's good. Good, good, good.
try to be try to be disruptive in a different space. So
It's easy to do, honestly.
yeah, I know it's really easy to do.
You can shake and rattle people on Twitter quite easily. It's funny. But yeah, so well, I appreciate your time. This will
No
be very
problem.
helpful. Hopefully Mark has a little bit. I'm trying to get Jim Hughes to talk to me about his thoughts on terrestrial weather and space weather. I know
All
he's
right.
doing a
Yeah.
lot.
Yeah.
And yeah, he's like busy right now, but he's like, yeah, later maybe. And I'm like, cool, as long as you talk to me about it, because I'd love to,
Yeah. I
because
mean,
we've dabbled on conversations because he took Tamitha's course when I did, and so that's how we
all right.
met. And
Okay.
yeah, but whew, should be
Yeah. No,
fun.
he's got a lot of interesting thoughts.
Yeah,
Yeah, there's definitely connections out there. It's just I think the hard bit is figuring out how it works.
yeah,
You
yeah,
know, uh, and that's the challenging bit. But you know, this idea of the Hale cycle and the ENSO seems to hold water, so to
yeah,
speak.
yeah.
But it's how it works because it's not photons. It's not the heat from the sun that's doing it. It's something
Nah,
else,
nah.
right? It's
Was it a combination,
there's
maybe magnetic pull and I mean, no,
I don't
anything.
necessarily think it's magnetism, but
No,
the problem
or
is that
flux or something like.
you've got to understand the chink in the armor of the atmospheric models.
Right,
So there's these things that begins with C and it rhymes with loud. They can't do clouds.
right.
So but if you think about what thing in the atmosphere moderates the amount of height that gets absorbed and reflected are clouds.
Yeah,
So if you've got a mechanism that can explain how cloud cover changes with depth and time and understand how clouds form, then there's every likelihood you might be able to see into how the sun affects
right,
cloud cover.
right.
And then how it affects cloud cover is probably how it affects weather or
Yeah,
climate,
yeah,
right? So there's it's well known in the climate community they can't do clouds, right? They can't model clouds, you can't parameterize clouds, you can't, but yet, and they all acknowledge they're critically important to the energy budget of the atmosphere.
yeah.
I don't know. I'm seeing a square peg in a round hole, right? And there's an
Yeah,
opportunity, right? There's an opportunity there. It's like putting on your X-like glasses and going,
yeah,
right? Like,
yeah, yeah.
hmm, maybe you're missing something,
Hmm.
right?
Maybe,
Maybe there's a piece of the physics you
possibly.
don't understand, which is why your models don't work. But that's exactly the same sentiment about the solar models,
Yeah,
right? So just to finish a point and let you disappear, the the solar models work great when you play them backwards,
right,
right?
right.
Because you've got 15
If
different, it's like
it's,
Spinal Tap, right? You've got all
yeah,
these different knobs to tweak,
yeah,
right?
yeah, yeah.
But the
But
minute you stop it and then turn off you keep the dials all fixed, right?
yeah.
And you let it play, it diverges in seconds, right? Like
Yeah. Surprise!
which basic which basically means you don't understand what's going on,
Yeah,
right?
yeah, yeah,
Far less predicting an event that's going to happen 10 years in the future,
yeah.
right?
It's quite
Please give
similar
me a
to the
break.
Met Office giving weather for up here and always being wrong. I'm
Hey,
like,
you know, you're
there's this there's this thing called the Great Glen. Really riffs your little weather thing you got going.
yeah, you know, it's funny because you're so close to that kind of magic latitude where you're seeing the Gulf Stream and the jet stream, and you're seeing the Arctic Ocean and the
Yeah,
interface
yeah, yeah.
between them.
Just
They
flying
don't.
because I fly out every week and fly in every week, and just seeing that the different grades of cloud. I'm always taking pictures. I'm like, what's that's a duvet there? It's like thick, and then there's a little stream, and then there's this, and I'm just like,
No, but
this is crazy.
that that is the and it's kind of like they always talk about the tropical convection, the tropical convergence zone.
Yeah.
There's polar convergence zones too, and they're
Yeah.
a fucking mess, right? But they seem to do a lot more because there's a
Yeah, it's
difference,
like a
catastrophic difference in the temperatures above and below them, right?
yeah,
And so
yeah,
it's
yeah.
like, but the weather people kind of get that, but because so few people live above them,
Right.
they don't give a fuck, right?
Yeah. It doesn't affect them, so they don't
Right?
care. Yeah.
Yeah. So they focus all their time and energy on the
Yeah.
tropics because there's shit tons of people around the
Yeah.
tropics, right?
Well, BBC
But
weather. Well, and in England it'll be this, and in Wales it'll be this, and in
in the
Northern
south of
Ireland
England,
it'll be this. And okay, what about Scotland? Okay, and the next news item, and I'm like, wait a minute.
well, and I'm watching all the political fun and games that are going on in Scotland right now. It's like
Uh,
I'm a Rangers fan, so fuck the SNP. That's all I can say.
and yet
Divisive
you live in
bastards. So I
America.
hope. Yeah, I hope. Well, actually, I was telling my daughter the other day, fighting those bastards would be the only thing that made me think about running for
Office.
public office. Yeah, because they've destroyed
I
my
just
country.
I just don't even know. I just want land further north on a hill, maybe Rogart, where my friend lives, because she seems to get into a lot of trouble with her car, and I'm always helping her. So go up the
Yeah,
hill with
right.
her, live up there, and not worry about the rest of the world. Live out the rest of my days, because I'm sure I got about 20 years to go. And it's like,
No,
I
I can think of worse places to be for sure.
know.
So anyway,
Yeah.
thanks for your time today.
Well,
I'm
thank
sorry I won't
you. I
see you in
appreciate it.
in Italy, so
Yeah.
I'll send money with Tom to buy a couple of huge bottles of Chianti, and everyone can get drunk
Ah,
on my
well,
dime.
yes. I'd say Chianti and olive oil, but that's always hard to smuggle in because they're not so fun. Because
Yeah,
my godparents live in Cinque Terre, and I go to see them twice a year, and I go, and then Mario's like, Lisa, come here, and I'm like, oh, here we go, big tub of olive oil. I get
yeah.
this for
Like
you.
here's a bucket of
I'm on
here's a
EasyJet,
bucket
and
of
I
wine
don't
for
have a
you.
checked bag. He's like,
Yeah,
oh,
right.
I put in a small bottle for you. I'm like, okay, do that.
It might not make it home.
Right. Exactly. So
Yeah, no, I love Italy. I'm really bummed that I'm not going.
yeah. Well, we'll
So
send you
I got to
pictures.
deal with. All right. No, yeah, tease me with it. That's fine. Well,
Yeah.
all right.
All
Well,
right.
have a great evening.
Thank
Thank you
you.
for your
You
time.
have a good
And
day. Thank
you
you.
know, cheers.
Bye. Bye.
Bye.